This is fall 2015 problem number 17. We have this configuration with a mass of 3m connected to a mass of 2m by a rope, and then another rope is attached to a mass of m that is hanging over the side by a pulley. I'm going to define the tension in this rope as T2 and this as T1, and we are asked to solve for T1. So the first thing to do is to draw the free body diagrams. And for the free body diagrams, we draw each object separately. So for the 3m object, we have that it is experiencing a tension of T2, pulling it this way, which we're going to define as the positive direction. The mass of 2m is going to experience T1 pulling it in the positive direction. And T2, the Newtonian pair corresponding to this tension, is going to be pulling it backwards. It's going to be pulling against it, and that's because if the rope is if T1 is pulling on T2, then if the 3m mass is pulling on the 2m mass, then the 2m mass is pulling equal and opposite on the 3m mass. That's our Newtonian pair. So we have that T1 minus T2 is going to be the net force on this. And then finally, the mass that's dangling is going to be experiencing mg down and T1 up. First thing we do is write those out as equations. So T2 equals 3m times a, the acceleration of this mass. For this diagram, T1 minus T2 equals 2ma. And for this diagram, mg, which is in our positive direction, because this way is positive, my mg minus T1, which is going in the other direction, equals capital MA, and we're asked to find T1. Now, one thing to point out with a problem like this, since they're all connected by ropes, and the string is assumed to be ideal and non-stretchy, they're all moving with the same acceleration. So A is the same for all of them, which is a really, really important simplification. So for step one, we're going to take equation 1, and we're going to substitute 3ma for T2 into equation 2. So what we get is, equation 2 is T1 minus T2 equals 2ma. That's going to be T1 minus 3ma equals 2ma. And that gives us that T1 is equal to 5ma. So once we know the acceleration, we'll be able to find T1, but we still don't yet know the acceleration. So let's go to equation 3, and we're going to substitute this value of T1 into equation 3. And so equation 3 is mg minus T1 equals ma. So we're going to write that mg minus 5ma equals ma. And when we solve for a, we get that a equals g over 6. Now we know what a is, we can substitute it back into this equation, and we get that T1 equals 5ma, which equals 5m times g over 6, which is 5/6mg, and that is our answer. It is C, 5/6 mg.